Welcome back to our channel ClassFly community. So today is the lecture 2, that is about the elasticity. The subtopics are explain elasticity, concept of stress and strain, types of stress, factors affecting elasticity, and Hooke's law. So the first thing which we know, it's about explain elasticity with examples. So elasticity is a definition about the definition is the property by virtue of which materials regain their original shape and size after the removal of deforming forces. So think of an elastic band like this. So when you stretch a little bit, so we are applying a deforming force, right? So it gets stretched. So when we leave the deforming force, what happens? It gains back its original shape, that is in the form like this, right? So this is being stated in this statement. So for examples, here it says rubber band and elastic and other stretchy materials display elasticity. And the different thing, or you can say the other thing that is inelasticity's example is like modeling clay, on the other hand, is relatively inelastic. That means whatever the form which we give at the last, that means the last modified thing which we have done with the modeling clay will be its shape at that form of time. Now we will deal with the concept of stress and strain. So first of all, we need to know what is stress. So when a body is subjected to deforming force, so think about that elastic band example. So deforming force is when we are stretching the elastic. A restoring force is developed in the body. What means a restoring force? Restoring force means it will gain a force of such type that it need to go back to that position. For that position, it requires some force. So that is the restoring force. So the restoring force per unit area is known as stress. And this restoring force is equal in magnitude, but it will be opposite in direction to the applied force. So if you are applying a force at the right direction, so it will be on the left direction, right? So if F is the force applied and A is the L area of cross section of the body, then T is equal to F by A. So this is the formula for stress. That means force by the cross section. And the SI unit of stress is Nm to the power minus 2, or you can simply say Pascal, and its dimensional formula is ml to the power minus 1 T to the power minus 2. The ratio of change in dimension of a body to the original dimension is called strain. That means strain is the ratio between the new dimension by the original dimension. And strain has no units or dimension strain. Okay, no units, and the dimension strain is equal to delta D by D. That means the new dimension which gets formed by the original dimension. Now we will know about the types of stresses. So first is the normal stress, that is if a force is applied to the cross section of the body. So if a force is applied to a cross section of a body, then the restoring force developed per unit area is called normal or longitudinal stress. So normal stress, other name is longitudinal stress. So whenever a force is get applied to the cross section of a body, then the restoring force get developed per unit area. Now this longitudinal stress can be divided in two parts, that is one will be tensile stress and other will be comprehensive stress. That means one can either be extended or extension will be possible for the tensile like this, and compression stress means we will do a compression obviously depending on the direction. Tensile means we will stretch it, whereas compression means we will press, right? In both cases there is a change in length of the body only. Now we will see the shearing stress. If a deforming force is applied parallel like this, if a deforming force is applied parallel to the surface of the body, there is relative displacement between opposite faces. So it will displace that side, one will displace this side. That means they are opposite to each other. The restoring force per unit area developed due to the applied tangential force. So the force which gets applied, it's in a tangential way. Now this shearing stress can also be known as tangential stress, or you can say shearing stress. Now we need to know about the factors affecting the elasticity. So material body generally can be single crystalline or polycrystalline, and correspondingly behave elastically different. So what happens in a material body generally can be single crystalline or polycrystalline, meaning that the crystalline can be one or many. Depends on what elasticity. Behave elastically different. Corresponding behave elastically different. Single crystal when subject to deformation show a remarkable increase in hardness. That means whenever a deformation is caused to a single crystal, that means a one crystal, then the deformation whatever happens is of a increase in hardness. And now we will see the effect of hammering and rolling. So hammering and rolling helps in breaking crystal grains into smaller units. So if you think of a glass, so when we hit a glass, what happens? It get into many different smaller classes, right? Small glass gets formed, which result in an increase of their elastic properties. The slipping starting at a weak point proceed with the grain and stop at its boundary. That means sliding between cleavage planes starting at a weak point proceed with the grain and stop at its boundary with the adjoining crystal. So no further flow possible makes that material hard. So it will not make that material hard. Now the effect of annealing. Annealing, heating and cooling gradually. So first we will heat, then again cool, and then again heat, then again cool. So this will favor grain growth in a particularly crystallographic direction, result in large grain or less grain boundaries in the body. Generally result in a decrease in the elastic properties or an increase in the softness of the material. Metal with smaller grains are stronger than those with larger grains. Sir Lawrence Bragg said in order to strong, a metal must be weak. So the simple thing you need to remember is what is annealing. Annealing means that heating and cooling gradually, it favors grain growth in a particular crystallographic. Then you need to remember that it will either decrease the elastic property or it will increase the softness. And you need to remember another thing, that metal with smaller grains are larger than those with larger grains. Okay. Now the next is the effect of impurities. Suitable impurities deliberately added can alter elastic properties. So when we add some impurities, some elastic property gets altered as they settle between the grains and brings connectivity between two grains. So it will either increase or decrease the elastic properties, depend on the elastic or plastic property of the impurity whichever is getting added. So think that carbon is added to molten iron, so there will be the increase in the elasticity of iron. Now the next is the effect of temperature. So if we increase the temperature, then the elastic property will decrease, and the elastic properties, so think that the elastic properties of inverse steel are not affected by any change in temperature. So this is an exception. That means in inverse steel there is no elastic properties which will get affected with any change in temperature. Now we will see the stress strain curve. So you can see that a graph showing stress strain of four materials. So the simple thing which you need to know is that C stretches more. That means this is the most ductile one because it extends or stretches the most. But D is also ductile but less than that of C because it breaks after a certain point of time which is less than C. B is the most brittle because it fractures suddenly. That means it gets die out at a small point of time. But A is the strongest and the stiffest. You can see that A is the strongest and the stiffest. So this depicts the stress strain curve. Now we will know about the Hooke's law. It states that stress is directly proportional to strain. That means stress by strain is equal to constant within the elastic limit, is called the modulus of elasticity, or you can say elastic constant. It is a characteristic property of the material. We show the force F exerted on a mass by a spring. So like this. So here also states that Hooke's law is a stress by strain in a certain elastic limit. So I hope all of you understood the topic of today. So if you have any queries, please comment us down below. We will definitely look onto your queries and reply to you. Till then, be happy and have a great day, and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.